Another force here we have to mention is tension. Tension must appear along with a string. Tension is actually the pulling force acting on the body by the string. So for example, if we're pulling a block here, there is a tension acting on the block in this direction. And tension exerts on every body connected to the string. So if there are two blocks connected, not just the T1, but also the string between the two blocks will also have the tension, like this. And tension along the same string is constant for a smooth and light string. Usually in the text examination, we will consider the string as smooth and light. If there is a pulley in the system, the pulley must also be smooth so that the tension on the same string is constant. If the string and the pulley are rough, then the tension will be different on both sides of the pulley. In this situation, the example will be much complicated. For example, you can see that when there is a block here, the weight will pulling down and there is a tension. And the tension acting on the block will be equal to the tension acting on the ceiling. In another case, if there's a weight connected to the block, the tension acting on the block will be equal to the tension acting on the block on the top. Even there is a pulley inside, because the pulley is smooth, then the tension of the string exists if the string is remain taut. If the tension will become zero if the string becomes slack. So in this case, you can see the string is slack, then the tension will be zero. And spring balance can use to read the tension of the string. So in this case, if there is tension T pulling on the string, then the balance will read T rather than 2T. So we should be very careful of this. So in example 13, you can see that if there is a tension pulling on the string, the balance in between, can you guess what will be the reading? It should be 10 on example A. And how about B? The reading also 10. So please be very careful about this. In example 14, we will see that the two blocks connected by the string. Then, how do we find the tension on both strings? Let's consider the block 5 kg first. You can see that the weight B and the tension B acting on the lower block. And for the upper block, besides the tension, there's also its own weight. So the second block is easier. So let's consider tension in string B. For the tension B is equal to the weight of the 5 kg block. So 5 times 9.x1 will be the tension on string B. And how about the tension on string A? We have to consider the upper block. The tension A will be equal to the weight A plus the tension B, so which is the mg plus T. In that case, we can formulate the equation by using the previous value. Then we can find the tension on A also. What if the string A is cut off? What will we get in this case? If the string A is cut off, the tension on string A should be 0. This is what we expect. Since the string B is slack in that case, when the two blocks is falling down after the string A is cut off, the tension on string B will also be 0. So this is the way to solve this kind of problem.